one of these beams can hold 2 point loads of 10,300 pounds. So it has a higher tensile strength. Bamboo.
Is it commercially available? Or
it's not. It's something that we've built ourselves. It's a prototype, but we're hoping to push it to the market. So. Other stuff about this room, there's bamboo flooring, and there's the recycled, this is recycled tea. A company called Ecoteric actually goes to lumber junkyards and fishes out nice looking pieces of wood and makes new furniture out of it. And this is what all this is. Recycled wood. Ecoteric. And yeah, so we're really promoting the whole renewability, sustainability, and recyclability of this kitchen. We try to define the two different spaces without using any walls, just to give it a more open feel. And so how we did it was we decided to lower the ceiling over the kitchen. It really defines the two spaces, but at the same time we don't compromise any of the space. So the layout of the kitchen is pretty standard. The sink here, appliances on each end of it, easy reachability. So speaking of easy reachability, for those of us who are a little shorter, you can't really reach the top shelves, you can have these installed in your cabinet.
Oh, yeah. All right, Brian, that's your next project.
Oh, I like that.
That's commercially available?
This is called commercially available.
Oh, just tell us where.
Honey, honey.
Stop this Home Depot.
But there's all this information's on our website, the contacts and stuff. You'll see the business cards laid throughout the house. Just grab one of the URLs on there and look all that up. And yeah, so we have here an induction stove. It's more efficient than a conventional stove. It only heats up if a magnetic surface is placed on it. And so I could turn this on, use it as a cutting board, but it won't heat up until you put a pan on it.
Wow.
So, and it's actually more. We really wanted to keep the private space closed out from the public. We've got the bathroom here in the middle, and actually a workspace here. And there's a window here. It's an electrochromatic window, which means if you run a current through it, and depending on the strength of the current, the tint changes. And this allows us to adjust the heat inflow. This can all be integrated into the sensor system once it's all set up. And so to control air temperature, all the windows tinting will adjust automatically. And in here, this is our bathroom. You see the jelly bean tiles that go all around it. That's actually made from recycled Coke bottles, rounded and just stuck on there like a normal tile. Looks great. Recycled glass tiles on above that. The company that makes these actually found a way to produce them at 50% the energy of traditional glass tiles. I don't know what they did, but they did it. A quarter of the energy used to make ceramic tiles. Got a dual flush toilet system for different water choices, and our sink and countertop. The countertop's made from recycled fly ash, and what that is industrial waste from steel manufacturing, concrete manufacturing. A recycled glass and concrete sink, and an adjustable flow shower head and a low flow sink closet. You guys want to head over to the bedroom? Recycled jeans installation, recycled cotton, treated with fire retardants and an organic pesticide, organic fungi. That actually keeps pests out. The walls that you see here is different from the rest of the house because it's not sheetrock, but it's a material called quiet rock. It's got 7 times the soundproofing as sheetrock does. We've got 2 layers of it back here, which really completely dampens out the sound of your washer and dryer when they're running. And we have it on this side of the wall because our mechanical room is all back there. And so if you guys want to
this is our mechanical room. This is by far the best part of the house. Forget about bamboo I-beams, all that stuff.
Yeah, all that pretty stuff.
Yeah, this
For
is
engineers it is.
Exactly, this is the best part. Cool. All right, so we have a 7.4 kilowatt photovoltaic system. This is a pretty large system compared to most household systems. What we use that power for is we use it to run all our electricity in the house. So photovoltaic panels generate direct current, which cannot be used by most appliances in the house. In order to be able to use that power, what you have to do is you have to put it through an inverter. This gray machine is right here. What the inverter does is it takes direct current and turns it into AC that your appliances can use. So up to this point that I've been talking about is what you would use for a grid tie photovoltaic system. A grid tie system is the kind of system where you generate power, and whatever's left over you sell to the grid. So as you can see, it's quite simple. Not a lot of machines, not a lot of complicated stuff. So essentially, all these two machines, this yellow machine right here and the batteries, are only required for a battery backup system. These are called bidirectional inverters, and what they do is they take the leftover power from the house and put it into the batteries, or take batteries take energy from the batteries and put it into the house at nighttime or during cloudy days. This is actually quite simple. If you don't look at this, this is all you need to go solar. We have one of the unique features of this house is the solar air conditioning system. What this is we have thermal collectors on the roof that generate very hot water. This hot water is used to heat the house, heat our water, but also cool our house. So the way we cool our house is through an absorption chiller, which is this machine right here. What this machine does is it takes very hot water from our thermal system, and through a chemical process with lithium bromide salts, it lowers the temperature of the water to very cold, almost freezing temperature. Then you pump that water through a small copper pipe and run a fan through it, and you get air conditioning. So in Phoenix, the hotter it gets, the better, because the hotter the day is, the more hot water you collect. The more hot water you collect, the more AC you get. So it's a system that's ideal for very hot climates. Also, the beauty of this system is you don't need very much electricity at all to run it. All you need to do is run a pump and run a fan. Normal air conditioning units use about 2 kilowatts of energy. They're very, very energy expensive. They're the reason why the grid gives out during the summer is because everybody's running air conditioning and everything just shuts down. If with this system you kind of solve that problem, you wouldn't load the grid as much during the summer.